afternoon, dear friends, and welcome to our popular HARDWARIO IoT webinar, an online event when we share our partners and our IoT projects and technologies. I'm Alan, CEO, and this is my friend Pavel, CTO and co-founder of HARDWARIO. And we would like to introduce Peter Klokočník, who is the founder of STATOTEST team.
Hello.
Hello, Peter.
So today we will talk about another example how HARDWARIO platforms help partners like STATOTEST to enable new applications that are actually saving human lives. They have very strong why. No bridge will ever fall again. And yes, we will talk about tilts of bridges, trees, and other structures that help in this area.
As always, we will start with the introduction of our partner STATOTEST, but today, luckily, we have Peter in the studio, so it will be his job. We describe use technologies, communication, and use cases. In the end, we will have plenty of time to answer all your questions during Q&A session. So don't hesitate to ask questions, use our webinar chat, and as I said, we will answer all your questions in the end. So Peter, could you tell us how this project has started?
At the beginning of the project, there were two well-known bridges. It was Troja Food Bridge in Prague and Highway Bridge in Genoa in Italy that collapsed. And it was the trigger for start of the project.
Yes, I remember Troja and this Italy bridge, but what exactly STATOTEST is? Could you describe more deeply this project?
STATOTEST is the complete monitoring system specialized in bridges, food bridges, high buildings, geological effects, sliding rocks, and things like that. Mm-hmm. Our goal is no bridge will ever fall down, as you mentioned in the start. And it also can be not only bridge, but also building and rocks. The current principle is very simple. We have system of sensors which can be easily connected to the structure or building. It can be connected by magnets or screws, and sensors can measure tilt, vibrations, some shifts, movement, and other physical things.
Mm-hmm. And how do you transfer data from these sensors?
Yeah, we use some public low-power networks like LoRa or narrowband IoT, and send the data to cloud. In cloud, the data are transformed, computed, triggered, and alerts are generated, and customers are informed by SMS or emails or application about some problems of the construction.
Great.
The inspection works 24 hours a day and 7 days a week. So you can work and be quiet every day.
It's like invisible guard for your bridge. So Peter, who is the typical user of your solution?
Yes, we help structural engineers, geologists, building engineers, building owners, and we help them to simplify their work and be in peace. Let's take a look at our promo video.
Even when we are all asleep, life is in constant motion. Nature flexes its might. We all know what it can do. Elements are at work. Something is always stirring. It all happens so quickly. It's a process which has always been here. Don't be afraid, nature. We know you're here with us. We know you very well. You seem innocent, but you can also be cruel. We gather data, every detail about the impact the elements have on us. We are creating a safe future.
Oh yeah, nobody can stop nature, but what we can do, at least, is to monitor the environment, to predict what will happen. In manufacturing, predictive maintenance is very popular and it saves a lot of money. But in the case of bridges and buildings, we are not talking just about money, we're talking about saving lives. The goal looks very simple, to monitor bridges, to monitor buildings. But what was the main challenge, the biggest challenge for you, Peter?
The barrier is that most objects has no sensors implemented, and the challenge was obvious: to install, easy to run, easy to install, and price affordable sensors to each object with some problems.
Mm-hmm. All right, Peter. So how about we talk about the technical aspect of this project?
Yeah, can you tell us something more about technical details of?
Maybe before we dive into technical details of the sensors, we should first talk about a bit of history of the project, because if I remember correctly, you have started the whole project with Tower, our IoT kit, where you have prototyped the whole solution. Actually, our core module in Tower is already equipped with accelerometer, which is the key component for detection of such events, right?
Yeah.
And later on, you needed something that is more robust, industrial grade, maybe more compact, and coming with narrowband IoT technology. You have made the transition from this prototype based on Tower to Chester, our NB-IoT/LoRaWAN gateway. The problem was that Chester is equipped with the same accelerometer, and you found out that actually the parameters of the accelerometers are not sufficient for the precision requirements of your project.
Yeah, it is, because we needed more precision sensors to measure tilt on buildings or some constructions. So now we used very high precise accelerometers, and we can measure tilt with resolution about 1,000 of grade.
Yeah, so we talk really high-end product in this case. It's something you cannot easily get, and we helped in a manner that we have created a special breakout board for this sensor that is directly integrated in Chester. We call it Chester X8, and it's dedicated for this application. I just realized that we are talking about accelerometers and these sensors, but we haven't explained like what's below the surface. We are talking about the sensors you are wearing in your pockets. You have these sensors in your smartphone. You have things like gyroscopes, accelerometers, possibly magnetometers, and all these kinds of devices fall in a special technological department called MEMS, which stands for Micro Electromechanical Systems. And essentially, these are really tiny mechanical structures, and it works on principles of typically measuring capacitance. They are like tiny jaws, and as you are moving the part, these jaws are actually changing the mutual capacitance, which are measured. It's awesome technology. And this is quite common parts today. And as Peter said, they really differ in various grades and specific applications. So we are using this extra precision device in this project. This was just briefly about the sensor technology. And let's talk about software, because for Chester, we normally have like ready-made packages. We have firmware applications that are solving different challenges, or we customize firmware for our customers. We create like specific behavior according to their needs and requirements. But your case was special. This was actually the very first time we have shared our firmware SDK and trained your colleagues, and you have developed the complete firmware application with the help of our SDK yourself. So can you tell us more details about the process and what you are actually doing with the sensor data from the accelerometer?
Yeah. From the start, we wanted to prepare firmware in our own company. So we wanted to use this specialized MEMS chip to measure more things that you prepared in the standard chip on the Chester installed. And in actual version, we use both sensors. We use MEMS chip installed on Chester and our high precision sensor, because this sensor on Chester is very low power. It is very easy to work every time, and our sensor is very precision but needs more power. So we use both of them.
And you are using our sensor like sort of preconditioning for the bigger sensor?
Yeah.
All right.
We use as trigger for measure tilt with high precision.
Interesting.
Yeah.
And how do you process the data? So you wake up your high precision sensor, then you read all the information, and what do you do with them?
Yeah. If we measure from this high precision sensor, we measure for some time, for 2 or 5 or 10 seconds. It depends on application. And we prepare some statistics of these data, which are collected inside. And from these statistics, we can find if the sensor is moving or is in stable position, on what has happened with this sensor during the measuring. So we use some statistics.
And when you say some statistics, can you go more in detail of what it means? Like if you do some sort of frequency analysis and things like that, or you process static data only?
We are preparing some frequency analysis, but it is in start just now. But mainly we use some minimum, maximum, average, and other simple filters.
All right, thank you. And when you basically filter the required values, you need to transfer them. We have already mentioned that you are using LoRaWAN and NB-IoT. I had a question, what's the decision point in the application, which transfer technology you will actually use?
Yeah, it depends on application. If we measure only tilt, it is no problem to use any technology because the amount of data is very low. But if we want to prepare some frequency analysis and other more qualified things, we need narrowband IoT, because there is a higher amount of data which can be pulled through the network.
All right, maybe I will make a quick note here, because for our out-of-the-box firmware packages, we have like predefined payload structure, but in your case, it was necessary to allow you to define your own payload, your buffer structure. So we have in HARDWARIO Cloud a specific port onto which you can send arbitrary payload, and you are doing your own structure of the packet and your own data parsing. But you are still using HARDWARIO Cloud as a service, which is like a bridging point to your own solution, to your own platform.
Yeah, we use HARDWARIO Cloud as bridge, because we work on bytes. We are using bytes in the transfer.
Just out of the curiosity, what's the typical payload size of the NB-IoT transfer? How many bytes typically, roughly, do you transmit from your sensor?
It is about 1 kilobyte. It's one packet.
It's fairly big amount of data.
Yeah. For narrowband or for low power networks, it is a lot of data.
Yeah, then now I understand why you need NB-IoT, and for some applications, LoRaWAN is hard to use. So we have been talking about data transfers to HARDWARIO Cloud. So let's look into this in detail. We support several technological paths how you can get data from device to cloud. It can be either through NB-IoT, Sigfox, or LoRaWAN. And in the beginning of our HARDWARIO Cloud architecture, there are so-called data parsers. These parsers transform the binary payload of the message to a JSON. And this JSON message is stored to our internal database. And the question may arise, how do I get to these messages? There are two options, well, actually three. You can see them in our web portal of HARDWARIO Cloud, and this can be very useful for your initial project setup and some debugging. And the second method is through REST API interface, so through industry standard REST API, you can paginate through the messages. We have full data retention for them. Or you can get, and there's a third way, you can get immediate asynchronous notification of the message through webhook, or we call it callback. So you can configure as many callbacks as you want, and the data will be delivered to your REST API endpoint. These webhooks are particularly useful if you want to integrate your data with already existing third-party services like Azure, Blink, Grafana, you name it. And you can also transform the payload that comes out of the parsers via a special query language we call JSONata. And basically, you can turn the original JSON message to any arbitrary form for your custom endpoint. So let's talk about the cloud solution of yours.
Yeah, from the start, we are using Microsoft technologies. So we use Microsoft Azure, Microsoft SQL, and Microsoft Web Services and other things. We also use Microsoft IoT, BLAP, and some stream analysis and other technologies from Microsoft.
Do you also use their visualization like Power BI, or is it something that you handle on your own?
Yeah, we are handling it own in the application, but we also prepare something in Power BI for some reports and regular reports and things specialized for long-term using.
Great. And what does the user interface look like for your customer?
Yeah. Do you want to see user interface
Just roughly describe what he can do with the data, what he can roughly see when he logs in.
Yeah. From the start, we wanted to prepare a solution very easy to install. It means sensors which are connected easy, and also the application to prepare to be very easy for customer. So we have also customers where we send box by post, check post. They open the box, install it on their own, and they got name and password to the application, and they can open application and they see their sensors and some statistics and other things, and they can prepare everything alone. So it is very easy for customer to prepare all things alone. Or we can prepare them also.
You can help them with setting up their project.
Yeah.
I assume that they can see the trends and everything, and they can adjust the levels, the notification levels when they will start receiving alerts. So.
Yeah. We must communicate also with them, with some specialized engineers I mentioned before. So some structural engineers, statistical engineers, which can help us to set these triggers in the right way.
Okay. How often do you typically send data out of the devices to your platform?
Typically, we send data after 15 minutes or 1 hour. There are also applications where we send data only one time a day. It depends on application and customer needs.
Okay. Because you are already getting some pre-processed data from the device, do you also do some kind of post-processing in your platform?
Yeah. We have some processing in the sensor own, and then in cloud we are computing some statistics and other things, some correlations of these graphs and other things
And today it's more like traditional technical analysis algorithms, or do you also consider implementing neural networks for the future to
what you
predict
see in the contemporary box, it is only classical statistics and classical methods, but we have prepared also some methods with using artificial intelligence.
Okay, so enough abstract talking, and let's see your platform in action.
Okay, I can show you how it looks from the customer point of view. Okay, I will log in to the application, name and password, and now you are on dashboard. You can look to sensors through maps. So here there are some bridge through something.
So this distinguishes the places, not the devices. This is like overlay with the projects.
Places. Yeah, the other view is through buildings. So you can hear how many sensors and is there some problem or not. You can look to the picture. Yeah, there are some small bridge. There is nice picture from Panchava waterfall, in the background, and there is some falling rocks in the front, and you can see sensor here. Yeah. Okay, I will show you some real data from this railway bridge. This is bridge in Prague, in Výtoň. This is steel construction, so the installation was very easy.
Is it the biggest bridge you are monitoring today?
Yeah, it is the biggest one. So we have two sensors, two accelerometers here. But 2 months ago, we made some measuring on this bridge, and there were 12 of them. So we are interested in this bridge more.
Yeah, obviously.
So you can hear these two accelerometers. You can see temperature, where last communication, battery. You can set some alert parameters and look to graphs. Yeah, this is graph from last day. And in each axis you can see how train goes through the bridge.
So based on this graph you can confirm that our trains are always on time.
Yeah. You can go through and here this time and how big was the train or how moved with the bridge. Yeah. The other building, what I can show you, the industrial hall in one factory. There is only one sensor installed on the roof of the industrial hall. There is very high temperature because it sends data only 4 times a day. Yeah, you can set the parameters and you can see how it looks. Yeah, this last day there is not so much movement. It is in some very small movement in last day.
So we can see that tilt is very stable.
Yeah, it is stable. I can show you more longer time. You can see there is some movement, but still in thousands of degrees.
Speaking the arts, can you maybe show how the configuration of the limits look like?
Yeah, I can show you where some alerts are set. So here in Brniště we set some alerts, and you can see when
Right.
it sends to the web, to email, and to SMS. And you can set some email and the telephone number where alerts are sending.
Really nice.
That's all.
Thank you for the demo.
Wow, what a great application, Peter, and good job. Could you tell me 3 main benefits of your STATOTEST project and application?
Yeah, it is easy to install, maintenance-free, and very, very affordable.
So when we're talking about easy to install, we are talking about seconds in some cases, right?
If you install this magnetic sensor on steel construction, it is in seconds. Yeah, you just put sensor on the construction and that's all.
That's wonderful. And when we are talking about maintenance-free, and that it's very, very affordable. What is the typical price of one installation, one sensor? We are talking not hundreds of thousands euros.
No. The basic price is about 80 euros.
80 like 80 euros
euros per sensor and month.
And so it's a solution as a service, what you offer.
Service with battery inside.
That's great. So you're right, very affordable, simply to use, simply to install. Great. Peter, now it's time to speak about future development, of project overlap, how you see the future of STATOTEST. Probably, and I know that you are working on new sensors and new features.
Yeah, we are working on new sensors because we cooperate with some academic institutions like Czech Technical University and others, and we speak with customers about their needs, and they told us what they need to measure, what they need, what type of data they want to capture from these buildings. So we are preparing some new things. You can see some shift measurement with inductive sensor. We have similar type with resistive sensor. We prepare sensor of strain with same Chester to measure strength of the construction.
So
we want to prepare some sensors which measure dynamics of constructions.
So there's development when we are talking about sensors. So you're adding new sensors. Of course, you are developing your application, all these things. And what we know that we are preparing the new network for transferring data, which will be based on satellites. So I think that the future is bright, right?
Yeah, I hope the future is bright.
Yes, and definitely I can see that many customers are really attracted by your solution, and that's perfect. So this was STATOTEST, our partner and partners project. As you can see, our most successful projects are our partners projects. That's why we built strong partners network. So if you are interested to become our partner, don't hesitate to contact us. On our website, you can simply book an online meeting with me or my other colleagues. And now it's time for your questions. So let's go to Q&A session. Hello, dear friends, and welcome to Q&A section. Question and answers. So don't hesitate. Please don't hesitate. Ask your question. You can see our webinar chat, and we will answer your questions directly here. Peter, Pavel, let's start with some obvious questions. I was just wondering about how many sensors it's typically you are typically using for one bridge. Can you tell us, is there some number you can recommend to the users, to the public?
Every project we communicate with special bridge engineers and statics, and it differs very much. So for small typical bridge, it is enough, one sensor is enough, but if you need to measure more parts of the bridge, it is about 10 sensors for one bridge.
As I remember, you mentioned 12 sensors on this special Viton bridge. So if it's a long bridge, you need.
It depends how big is your bridge, how is complicated to measure it, and how much money you have.
Yes, yes. This is a nice bridge to my next question about the price, because you mentioned that the cost is 80 euros per month for one sensor.
Yeah, this is.
It's a price which is not only for hardware, but for application, for some maintenance, or what is included in this price?
Yeah, it is. This is price for, you have one sensor for 1 month. So it is included with cloud, with some reports included in this system, and also battery is inside this price.
And this is very important, that that you cover the batteries. Just in case they will promise you some battery lifetime, you can be satisfied with this kind of service. They will replace it for you. So that's
hassle-free.
Yeah, hassle-free. Perfect. Maybe Pavel, you had some.
Oh yeah.
question.
Actually, I have one, because we have been speaking about basically one-way direction of communication. But in your case, I remember that you have implemented some kind of back channel parameterization for your devices. So maybe if you can go into detail.
Yeah. We solved back communication with LoRaWAN. LoRaWAN, but with narrowband IoT, we don't have this communication.
Yeah, we are planning on this feature together.
And you can set some frequency of measuring and some triggering of parameters. This is two main things you can set in the device.
And speaking LoRaWAN and NB-IoT, what's like your experience with the signal coverage and availability?
Yeah, we have very good communication with Czech radio communication, which help us with LoRaWAN network in Czech Republic. And if we had some problems with coverage in past, they improved the coverage with adding some bridge or adding some other device.
They build a gateway for you, and the signal is provided.
It was very good. And with narrowband IoT, we have no problem with coverage. Only one place in past, it was in this Pančava waterfall, you had picture before, and there was some problems with communication, and we solved it with external antenna.
Yeah, that's what we have in the accessories. So we actually have one like over 1 meter tall antenna, and we have solved so far every problem.
Only small one.
Only small is enough, right? Good, thank you.
But what is perfect, speaking about those two technologies, that we can inform you that we already have a new version of a Chester device, and we have a new chip there.
Shall I present the secret?
Yeah, present the secret, but the important is that...
you can see it's prototype, so some wires hanging from it, so this is just a tree. Yeah, it's coming, but still in the labs, in the deep development stage. And yes, there is actually a possibility, to actually switch between the internal antenna and external. This represents the external, but can be connected through UFL cable to external SMA connectors. So the whole variety of antennas can be attached to it, and by software you can switch between internal antenna, external antenna, and LoRaWAN and NB-IoT. It's all software configurable for the future. Of course, we will not populate all the units with both modules. It will depend on the application, but for our partners, we will have this flexible, fully featured edition covering all modes, all operation modes.
And for us, it is also for critical applications. We prepare to have both connections LoRa and narrowband, and if something fails in these steps during communication, you can change to other technology.
Yes, exactly. It can be like a backup channel for extra reliable networks.
There's one more big thing what we achieved last month. We send data through satellites. So maybe it's even surprise for Peter, but we had first successful transmission over satellites, Argos, because we implemented technology which is called Kinase. And so we will be able to send data through satellites. In this case, you can really monitor bridges even in Africa, because we have one nice project there with elephants.
Yes.
So, endless possibilities with our technology and your technology.
Yeah, we are waiting for it.
Together.
And a little bit of advertisement for our podcast. We will talk about details of Kinase satellite technology in our HVDev podcast. So if you are interested, just subscribe. And I'm not sure if it was already released, but at least it was recorded. So you can hear some details about our experiment.
It is for not Czechs.
Let's check language.
Just check language. But sorry. So we have a first question here, from the web chat, webinar chat. Jakub Rybář asks, I do see a lot of use cases for STATOTEST, as well as competitors, which might be partners. What is your biggest challenge in this time? And any cooperation with Neuron Somewhere? Would it make sense? I don't know if you know Neuron Somewhere.
I know.
Because they are our friends. Yeah. Hello, Pavel. But if there is any ideas, in your head, how to cooperate or make a partnership.
We are open to any cooperation in future. So we can speak with any company which measures bridges, measure something. So our goal is, you told it in the start of the webinar, that no bridge or no building, no structure will fall again. So we don't look around who is competitor or who is who, but we need to solve these words.
That's great, because we are open to any partners. So if you have, and Jakub adds another nice question, and maybe it's not a question, it's a proposal, because he asked, are you looking for customers in different verticals? And you already answered this question. Yes, they are. Or are you ready to scale up out of CE region? I might know about some prospects in Spain. So maybe you can start with this, that, because you have nice partnership with Microsoft in this time, and we know that you are talking to very important people there. So hopefully your technology will spread around the world soon. But this is a nice proposal for Spain. So
we don't have in Spain. We have only Czech and English. But if there will be a lot of customers in Spain, we can prepare.
And good news is that Spain is fully covered by NB-IoT. So
it's good.
This is maybe we can follow with this about your typical user and customer. What's your target group?
Yeah, you talked about some competitions, but we see people who are structural engineers, geological engineers, some bridge engineers, bridge monitoring companies, and other monitoring companies. They all can be our customers too. So we want to help them to measure in some deep valleys and places where it's very complicated to install some classical measuring system. So we can solve these things for them, and on the other side we can use them for this knowledge, because we don't have so much knowledge from bridges and structural engineering. So we can cooperate with anybody who can help us or who we can help.
I know that because this is another thing that we as a group of partners, we cooperate closely not only in speaking about technology, but about sales system too. So I'm kind of part of your team, and we are trying to find the best way how to reach customers and how to make sales as a system. So I'm pretty happy that you got some results and real results, and you are selling a device every day, and it's very promising. I'm so happy about this. So it was about, yes, so they are ready, go to Spain. Yes, I understand. Okay, Pavel, another question, or we will continue with my...
Please go ahead.
Okay. So this is, if you can describe the way how customers and people can reach you, what is the process, how they can reach you, and how long it will take, when they are, describing their problem, and you will deliver results like through your application.
How to reach us? It's very easy. You can call me, write me email, or look to our website statotest.cz or statotest.com, and you can find place with me to communicate on Microsoft Teams. So you can order one half hour meeting with me. It is the easiest way. And how long it takes? It is about 1 or 2 weeks to start with measuring some bridge, some wall, some structure.
Yeah. So I will ask you if you have any other questions. Just you have a few minutes left to ask this question to our webinar chat, and we are, basically we are in the end of our webinar with you, and we were so happy to have you here in our studio. We are looking forward to have more more use cases and successful stories, how you are saving lives and money and everything. If you want to something add, to say something which is very important to you and to do our...
Thank you, Alan, very much for inviting me for this seminar. I was like to tell you something and to improve some knowledge about measuring and monitoring systems. And I will be happy in future cooperation together with you.
So this is it. There was Peter. Thank you, Peter, for everything what we are doing together. As I mentioned during the webinar, we are building a strong partners network, and so if you are interested, don't hesitate to contact me in our webinar chat. There is a way how to reach me, how to book directly an online meeting with me. Thank you, Pavel, for your technical support, and
welcome.
And see you soon. See you next month. We will have another successful story, another great partner of HARDWARIO network. Thank you and have a great day.
Thank you. Bye-bye.
Bye-bye.
Thank you.